आज का हमारा टॉपिक है रिलेशन बिटवीन EMF ऑफ ए सेल एंड गिव्स फ्री एनर्जी चेंज। इलेक्ट्रोकेमिकल रिएक्शनों में हमें रिलेशन निकालनी पड़ेगी EMF दैट इज इलेक्ट्रोमोटिव फोर्स एंड गिव्स फ्री एनर्जी चेंज दैट इज डेल्टा G। For that we should know that the electrical work done or electrical energy done in an electric circuit is always equal work of electrical is always equal to product of EMF of the cell and the charge that flows through the cell. Since the work is done by the system, we can use the negative sign. That's the electrical work done in a system is equal to the product of the charge that flows through the system or the cell and the EMF of that cell. If N is the number of moles that are transferred in the redox reaction, total number of electrons N are involved in the reduction reaction, then Q is equal to, that's total charge is equal to N dot F, where F is the charge on 1 mole of electron. We see if N moles are involved in the reduction, charge on 1 mole is 1 Farad, it is Faraday's constant, 1 mole charge. Multiply it by N, at that time total charge will be equal to N dot F. 1 Faraday, it is a charge on 1 mole of electrons. Therefore, we can say that work of electrical is equal to minus EMF of cell into N dot F. Or we can write like this, minus NF E cell. It is an electrical work done, that is number of the moles of the electrons involved in the reaction. F, it is the charge on 1 mole of the electrons, and E cell, it is the EMF of the cell. But at constant temperature and constant pressure, the free energy change is the useful work done by this system. Free energy is converted into the useful work. Here the del G will be equal to work of non-expansion. That is the electrical work done. We do have 2 types of work. One is the work of expansion. Expansion was pressure volume relation, already done in the 11th class. Now we do have the work of non-expansion. It is in case of the electrical circuits. Means delta G is equal to minus negative times work of non-expansion. That is work done by the system. That will lead to the decrease in the free energy. But here the work of non-expansion is equal to the work of electrical energy. Or we can say that delta G is equal to work of electrical work. Electrical work will lead to the decrease in the energy. It is itself a negative quantity. It will decrease the value of free energy. But already work of electrical is equal to means del energy is minus NF E cell. But work of electric energy is del G is minus NF E cell. It is a relation between the free energy change and the EMF of the cell. But if the measurements are carried out under standard conditions, that is 298 Kelvin temperature, 1 bar pressure, and 1 mole concentration. At that time, we can write it like this: delta G naught is equal to minus NF E naught cell. It is a relation between standard free energy and standard EMF of the cell. Let me repeat it once again. The electrical work done in an electric circuit is always equal to the product of EMF of the cell and the charge that flows through the cell. EMF of the cell means it is a total potential difference between the electrodes. We will do that in the next topic. Now there is a charge. Charge is equal to N dot F, where N is the number of moles involved in the redox reaction. Redox reaction means number of moles lost by the anode and the number of moles of electrons gained by the cathode. In an electrochemical cell, oxidation will take place at the anode. Anode will lose electrons, whereas the cathode will gain the electrons and the reduction will take place at the cathode. Total charge will be equal to Nf. F is charge on 1 mole of electrons. Electrical work done will be equal to EMF of the cell Q. Substitute the value, it is minus Nf. Also at constant temperature and pressure, free energy change, that is the Gibbs free energy change, is always equal to the work of useful energy. That is delta T will be work of non-expansion. Here it is electrical work. Or delta T is equal to work of electrical energy. Therefore, we can say that electrical work energy is equal to minus Nf E cell. Or electrical work is del G is minus Nf E cell. If the measurements are carried out at standard temperature and pressure, at that time delta G naught will be equal to minus Nf E naught cell. Now there is a significance. What is the significance of this relation? Before significance, we should know one thing. That is, a process is spontaneous. If the process is spontaneous, delta G is always less than 0, that is negative. For non-spontaneous process, delta G is greater than 0. If it is equilibrium, at that time delta G is equal to 0. These are the three conditions for spontaneous, non-spontaneous and equilibrium. Now the significance of this relation is that it gives the feasibility, that is spontaneity of a cell reaction. For a cell reaction to be spontaneous, delta G must be equal to negative value, that is, delta G must be less than 0. Now, delta G will be negative if E naught cell is positive, because N, it is the number of moles of the electrons, it can never be negative. F, it is a charge on 1 mole of the electrons, it is always positive. Therefore, E cell must be positive for delta G to be negative. Or we can say that the cell reaction is spontaneous if EMF of the cell is positive. Similarly, if we will have to find the non-spontaneity, for non-spontaneous process, delta G must be greater than 0. For non-spontaneous process, delta G must be greater than 0, which is possible only if E naught cell is negative. Negative value and negative, that will become positive, and delta G naught will be positive. For equilibrium will be if delta G naught is 0. Delta G naught is equal to 0. It is possible only if E naught cell is equal to 0. means the current will not flow through the cell. At equilibrium, E naught cell will be 0. Now our next topic will be Nernst equation.